Welcome to the sixth lecture of Map&Models, and today we're going to talk about crawling data. And before starting with the coding part, because today the course will be very much in coding, we wanted to just have a sum up or a recapitulation of the concepts that we have been discussing through the lectures. So we always show you this, let's say, table where we have on the one side, we have the side of the map, of data, of machine intelligence, objectives, and numbers, and today we add one new line that is called local globality. And on the other side we have model, information, intelligent humans, personal, geometry, and global locality. So as I said, as we said, every lecture, these symmetries are always
presented.
Yeah, they are presented, but as they are being worked, so they haven't been set on stone. They are always open to discussion, and then if you have to think of a new one, it will be really interesting for us to discuss about it. So, as I said, we're going to sum up a bit of what we have been talking in the last lecture. So, we talk about the world, so our planet is complex and is inaccessible as it is. So in order to describe it, we always use abstractions. And these abstractions are created with instruments. And these instruments are maps and models. So we also introduced the theory of Alfred Korzybski, that he said the map is not a territory, but we propose that to replace the map is not the world. So an ideal map will contain a map of the map of the map endlessly. So this is just one abstraction of the world. And in relation between the map and the world, we add the notion of a model, right? So models are specific renders of a map that is trying to represent or trying to abstract from reality. So maps reassemble facts of the world with any dimensions or with n dimensions, and without rendering or representing its data. But models are the representation or the projection of this data. It comes from the map. Okay, so we also talk about the model of natural communication introduced by Elias Safiris. So if we apply this model on this relation between a model and a map, we see that they belong to two different domains, and they are communicated between bridges that are built, for example, an encoding bridge from machine intelligence and a decoding bridge from intelligent humans. What is interesting about this model is that these domains, together with the bridges, are always in a cyclical movement. And we say they are in the cyclical relation. So if we emphasize on the cyclical relation, we see that we have, again, this movement, and in the center, what we are trying to describe is the world. So our intention on this course is that we identify each of these concepts on each of its position on this model, so we can act specifically on them. So what are the things that we have to do in order to create a map, in order to create a model, and the bridges are the instruments that we use to do mapping and to do modeling. Okay, so now that we have a background of how we think or the concepts that have been introduced in the course, I will just replace these concepts with the task that we're going to do on the experiment that we are proposing to you. So we said the model, right? The model is a representation of the world. And in our case, the model will be everything that is contained on the internet, let's say. So this is already a preconception of what is reality. And we will use the first step, that is a collection of data or crawling data. This is one instrument from machine intelligence that will create this map or this collection of numbers that are transforming any type of data into numbers. So this is vectorizing any type of data. This will come from the next lecture. Right? But the thing is that when you did this cycle, you end up on the part of the intelligent human, which is the decoding bridge. And here what is interesting is that you always have to come up with a question. Why is this important? Why should I keep on cycling? So this question is the one that we are going to ask you to think about, because it's important that you have the intelligent human in this model in order to create, in this natural communication model in order to create a model. So next cycle of the experiment is we ask the question. So for example, we have a hypothesis that cities in the world, they behave similar if they are in similar seasons, for example, or paintings that have been created for Renaissance have a similarity to paintings that have, I don't know, modernity. Any question is valid. We just need to bring it to this model and see if it can be answered. So next level, you say, okay, we define these categories. We have these two, let's say, in the case of the cities, we have the seasons. We have 4 categories that we want to work with. And then we start the clustering process based on these categories. So from the model of categories, we use machine intelligence to create, again, a list of numbers that can then be used to answer the next question, right? So then this level or this cyclical movement that we're seeing in the experiment always closes the circle, the question the user or us are having in this experiment. And so we keep on rotating, and then you will see in each cycle you have a specific, let's say, renderings of what is a model and what is a map. And so this has to be, you have to be conscious about it, and you have to, in a way, explain through your experiment these 2 domains and how the bridges are being connected. Right? So the idea is that since it's a cyclical movement, then you, as an architect or as the student of architecture, will decide when to stop the circulation. Because the stopping is really important. There you render your specific intention and your personality. So here you're creating a model that is representing, or that is answering the question you had at the beginning through many cycles of questions and of using of instruments to modeling and to mapping. Okay, but the interesting idea is that these cycles are not individual, so they are not happening one then the other. They are always happening on a way of a spiral. So one is the input of the next one, and the next one is the input of the next one, and so on. So it's creating this connection. So the idea is that since they're all connected, when you arrive or when you decide to stop the cycle, you can always come back. And you can always make a different decision. So this spiral, it's a certain point fixed, because you have taken decisions on the way, but the idea is that you can always come back and decide differently. So it's not a fixed, let's say, movement. It's a movement that you can come up and come down. So this is, let's say, a more abstract representation of the experiment, but now we're going to give you a more clear, graspable understanding of what are the tasks that you're going to do through the experiment. Want to explain?
Yes. So here we see is the let's say a flattened diagram of the experiments we are going to propose. And for this semester, we will specifically focusing on Twitter. So basically, we collect Twitter images, Twitter text, and then we ask questions on top of them. And then, if I click, yes. So basically, here are the main steps of our experiments. So at the beginning, today, which means we are starting to collecting data, and then later we convert this data to their numerical representations, which works somehow similarly as the coordinates we show you in the last lecture, so that these data can be managed by the machine intelligence algorithms. And then later we will fit this data into a specifically self-organizing map, which is the algorithm, the instruments we are going to use through the whole course of this semester. What's happened to this?
Wait.
Yeah, to this semester. And then with the self-organizing map, we are able to, let's say, starting ask questions. What happened to this?
Yeah, just to
Yeah. To ask questions and then to for example get our answer and then have our specific rendering towards the data we have. So basically this is the experiments we are going to propose. And then so also I think from this lecture we would like to ask you to start think about what kind of question you may be interested regarding let's say cities or people or buildings or anything. I mean anything that can possibly you can possibly to find answers from social media. For example, how what kind of the for example the different atmosphere of different cities, for example, or I don't know, in different places that do people talk, let's say, about the same thing or different things, and then what would be the I mean, when we are referring for the same things, how do people in different words talking about it differently? I mean, for example, these are just the simple examples, and then we are expecting you to kind of develop your own questions regarding something that are happen in the city, that are related in the city.
Yeah, so I think it's really important that you know or that you create a hypothesis of something that you think it's happening.
Yeah.
So then this hypothesis is how you're grasping this many type of data from social media.
Yeah.
And then with the hypothesis or assumptions that you have, you can see if they are actually happening. So this is the question. So you think of something that can be happening, or you want to see something, or you're interested in something. Then this is exactly what we want you to write about. So at the for next lecture, we want you to write a short 1 paragraph length of what you want to find or what you're thinking can be happening in cities, in buildings, in society, and so on. Everything is valid, and the only limitation is that we will only work with social media data.
Yeah.
Okay. So we continue now with the part of the code. So we will give you 5 minutes to download the code, and then you can now open the Mathematica file.
And as usual, the code will be in the teaching section of our webpage.
Yeah, so it will
be lecture 6.
Now that you have downloaded the code of this lecture, you have to open the download folder and open the folder that is called code, and then inside code you have a file that is called crawling data. So in this file, what we're going to learn or what we're going to try are different ways of crawling data, but first we're going to describe what is crawling. And in order to know what is crawling, we need to know what is a crawler. So crawler is described as a bot, as a robot, an algorithm that is systematically browsing the World Wide Web. So you have different ways of accessing data. For example, you do it every day when you're searching on your local files. But this crawler, what it helps you is to go through the web and collect as many data as you want. And in order to crawl or to collect data, you need sometimes an API key. An API key is a short for Application Programming Interface. So if we have an example, if we go to a restaurant and the waitress comes, we tell him what we want. He goes to the kitchen and he tells what we asked, the kitchen cooked, and then he brings it back. So in this example, this API key is the waitress. So he is the one that allows the communication from the user to the system. And this allows also to keep track on how the things are happening when you're asking data or collecting data from that platform. So that's the role of the API key. And many platforms provide you an API key to access their data. So for example, if we go to Google Maps, I have now a screenshot of what you will get, but if you click here in this image, you will immediately get redirected to how to get an API key in order to access data from Google Maps. And in the same way, if you go into Science Direct, this is a platform where you can find academic writing in many formats, so books, journals, or magazines. And in the same way, here you can access this data by asking an API key to the platform. Again, with OpenStreetMap, the same way. If you click each of these images that I'm presenting to you, you will get redirected to the original website, and then you can inform yourself on how to get an API key. And then, of course, at the end, I add this Twitter API key that you can ask as well. But in this course, we will collect data differently, and then this we will show you later with Geo presentation. Right, so we know what is an API key, but how does an API key look like? So an API key may look like this, a long string of numbers and letters. Right, so how to use it? Here I have an API key, which is my API key, but it will only work now for me currently to use it. So you have to enter your API key, and when your API key is entered, you can run this line, and this line is creating 3 variables. It's creating the variable of my API key, and is now creating a list of cities where to crawl the data. And so here I have 4 cities, and here if I ask what are the coordinates of these cities, which is this variable, it gives me already a list of coordinates. You can add elements or you can subtract elements of this list, and still this algorithm, it gives you a list of their coordinates. So here, for example, to use an API key, you need to understand the structure of the link where you're going to crawl. So this is a link of Google APIs, it's called. So here it asks you for the latitude, the longitude, the zoom level, the image size, and the type of map. And at the end, of course, it asks you the API key. So we have already defined what is an API key and what are the coordinates. But here it says, it asks you, give me first the latitude and then the longitude. So we have to split the coordinates in these 2 formats, latitude and longitude. And then we have also to define parameters like image size, map type, and zoom. So if we run this line, Shift Enter, and if we ask for the first variable, which is latitude, you see that we are getting the first elements of the coordinates that we have created. Right, so these elements now will be mapped in this element here to get 3 maps of these, 3 Google Maps of these 3 cities that we defined here in the top. Right, so now if I run this line, I will get 3 cities, 3 images of the city with a zoom level of 14 and an image size of 1000 by 1000. But what about if I set a zoom level of 18? You will see that it changes how much information you're getting. And we can not only do that, we can also add another city, and we can say, I want New York. Here, you do Enter. Sorry. You do Enter,
And also,
Shift Enter.
And also this box is called out by pressing Command.
Yes, Command equal. If you do Command Control equal in Mac or Command equal in Windows, you will get this orange box. Right, so now we have added another city, and then if we run again this line, you'll see that we have now 4 latitudes, and if we run again this line, we will have 4 images of the city. This is how you will use an API key. You have to know the structure of the platform, and you need to know where exactly to enter the data. And of course, you see at the end, we have the API key request. Okay, so now how can you get access to data? In this course, we use Mathematica, and of course, Mathematica of the Wolfram platform has a lot of data to work with. So first, they already have access to a platform that is Digital Globe. So here you can only ask for a city. You run this line, you see I'm asking for a city, and I'm searching the position of the city, and then I'm getting the city. And you can also do it in one line, which is what I'm doing here. If you run this, you will get exactly what we're asking with the city. And in this gear range padding, you can ask how much the area you want to collect from this scroll. So if I say 5 kilometers, you will see that it gets more close. Okay, also we can find data from Wolfram data resources. So here we have data, demographic data, which is very interesting as well. So I just have here a list of countries. In the same way, if you want to delete or if you want to add or change, you have to put a comma, command, enter. You create this box, and then here you can type, for example, we can add Peru here. Enter, and then Peru is created, and shift enter to run the cell. So now we have a list of countries with the variable countries. We should also run this cell that's called categories, because those are the data titles that we will ask for. So here, when we say administrative divisions, let's say we take the data of administrative divisions, we put it here in this string, shift enter, and then we will get the divisions of each country found in the database of Wolfram. So here you see, so for Ecuador, the administrative divisions are Azuay, Bolívar, Cañar, Carchi, Chimborazo, and so on. And then you can also change any value for the ones that I have given you here. So for example, I can say I want to check for the child population, and I replace this value, shift enter, and instead of getting the administrative divisions, I get the value of the child population. So somehow it's just like working with lists, and you can ask questions to this type of data, and you're accessing a database of many information regarding about countries. So one way of accessing data, or one type of data that you can access through Mathematica, is demographic data. Another type of data, it's what is called a training data for machine learning. So here we can go to this link, training data for machine learning, and then you find many databases or data sets that contain many different types of data. So here it's just one example. I'm asking for the data set that is called sample data from wine quality. If I run this line, if I ask for what is data, the length of the data, it's telling me I have close to 5,000 wine quality inputs. And I'm just visualizing 5 of them. So here, one example is if you check on this link that I'm giving you here, you will find very interesting data sets that you may want to work with as well. And another way of accessing data here is, this is a different way of asking this type of data. So you say, I want to, again, use a machine learning. This data will be used for machine learning, and I want the movie reviews data. So when you say long description, it is explaining you what is this data about. So this data consists of more than 10,000 snippets of movie reviews, and so on and so on. And then it's telling you either it's positive or negative, and this was I get it from Rotten Tomatoes. So if we run this line of data, we are splitting this whole data set into training data and test data, and I'm gonna only visualize 5 elements of it. So if you say a sentimental hybrid that could benefit from the spice of specificity, so this is rated as a negative comment. And then you can also have a positive comment, which is an interesting psychological game, and so on. Yeah, this is one way of getting data. The another one, again with Mathematica, you can access any type of data. And here what we have created a list of words that are, for example, is city translated in different languages. So we have city in English, we have ciudad in Spanish, we have Stadt in German, and then we also have in Chinese. How do we say city in Chinese?
城市.
So we have that in Chinese. Okay, we say we want only 5 elements of each word, and we want images that are related with this word. So we run this line, and we run the second line, and now you will see this slider is telling you how, like now it's collecting the first list of pictures, now the second list of pictures, the third list of pictures, and when it's done with running, it gives you now a list of how the web or how people are referring to cities. And we already see that they are different. So we cannot assume that everybody sees the city as it is, But just simply with this small exercise of changing the language when referring to a city, we see a variety of different ways of representation. Okay, so we have another type of data, or another resource of data, which will be social media, and this will be explained much in detail now with the GUO in the crawler of Twitter. So here is just one short sample. Here we define, for example, a keyword. I say I want to search Twitter by Tokyo. You can say I want to search Twitter by news or by coronavirus or whatever. So here I run this line. Now it's open in the browser, saying, okay, here I find that my keyword is here, Tokyo is correct. And then if I just split my screen so you can see what is happening. So I define iterations, means how many times I'm going to scroll down Twitter. Here I say 3 times, and then you will see what is happening here. So this is the first, this is the second, and then it's the third. And I'm going to get all the tweets here. And if you run this line here, it will give you a postcard of Tokyo by 6 images.
Yes.
So this is a postcard of Tokyo. And you can make it even bigger or smaller as you wish. So this is how we're working, how we're collecting data. Another way of collecting data, this could be data from social, for example, from social media. So here, Mathematica has already an API that has been assigned through Mathematica. So here we connect to that API. We sign on Twitter. I use my account. It's there. I authorize the app, and then it gives me this number. When I copy this number, and then I paste it here, and it's done. Now we have created our API key and we can use it. So again, I say I want all the tweets that has the word Tokyo. So I run this line, and now it's collecting all of these tweets. Instead of doing as we did before, opening the browser and then scrolling, now it's getting, because we have the API key, it's already accessing the data immediately. So here we have everything already structured. So let's say I'm only gonna take the text of these tweets, because you see it has ID, it has creation date, it has entity, it has a lot of data, but I only want to work with the text. So here are the text of all these tweets. So that's how you can access text from social media. And then, for example, what's also interesting is that you can get data from anyone in Twitter. So I define a username. So for example, Emmanuel Macron. And then I get all the tweets that he has tweeted previously. And then I can also get all the text that he has said. So this is how you can extract data. It's only text data from them. And this is also interesting that you can ask for the followers of this username. And then here are all the followers he has. Okay, and one last way of getting data is with OpenStreetMaps. So OpenStreetMaps have let's say an interface that allows you to get data easily and more structured. So for example, here, if I click here, I get to this very nice interface, and here we're gonna crawl OpenStreetMap data from Lutzeri. So we're gonna go to the wizard, and I just to try out, we're gonna work with highways. And so I want to use highways. I do a build query, and then I run it. Build and run query. So now you will see, now I will get a lot of lines and polygons that are referring to the streets. I already crawl many of these small samples, and you will find it in the code lecture here. So for example, we have building, iron, we have land use. Okay, so here are all the ones that I have crawled for you already, in the same format as I show you. And you see that when I ask, here I said I want this category. And in the file of Mathematica, I already give you this, because here are the features on how to ask this data. So just have a look on here, and then you know how to ask specific features here on this platform. So now I'm gonna ask for the rows of the rows from the side I want. And here, if we run this is how we graphic the road network in a background of white. And here's how can we have the info. And then if I run this line, we will see the geometry of it. I'm going to go a bit fast on this side because we are not going to focus on, let's say, on shapes or on this type of data, but I just wanted to show you that through this file you can access any type of data, and then we are giving you already examples on how to do it. So I will, on the side, I will run all of these lines. Okay, so all the lines have been run, and you see that in the first line we have one representation of this data, which is in black color, but our concern was, can we change the color in order to make it more, say, appealing? And we did it in the roads. We can also do it with the buildings, and then you will see that it's happening in each of these different elements of the city, so land use and natural as well. And since this is kind of a database, you can access their data such as a way that you say, I want the third element of the second list, and I will want only the element from the first to the 50, and then you have this. So this, for example, in natural information, you get the first element is water, and then it's drawn as a multi-polygon, and then is a river. So then you have different, you see that you are accessing the data, even though it's rendered as points or lines here in geometry. And then this last line, what it did, it compiled all the different adaptations we did to the map. So we changed the color of the roads and so on. And this file, you can use it in Illustrator or in any software that you use to modify vectors. So what you do is you save graphics as, you set PDF, and then here, for example, now I have in my desktop this code, so I'm gonna put it here in my folder I create that's called test. I call it test, I save it, and then if I go to my desktop code and then the file that I just created and open it in my with Illustrator, you will see I can edit it and do whatever I want. Just this fast exercise if you would like to work with this type of data. So if you have any concerns, so here you see there are vectors, and then you can work with them. So for example, like I create different layers, and then when I select, I ungroup all of these. I select, give me all the same, select same appearance, and then I put all of these on the fourth layer. I can turn it off. Then, for example, this, I move it to the second layer, turn it off, and then I just select all the streets, select same appearance, and then all the streets are here in this layer, turn it off. Now I have only buildings, and then if I come here, I say I want only buildings, select same appearance, and move them all to a different layer, and turn it off. And that's how you can start working them in a software you know it well. Okay, so that's from my side. So that's the different examples of how to collect data and how data is being rendered in different platforms.
Okay, so let's continue. So now will be the last part that we will introduce the Twitter crawler that we are going to use for our experiments. And the code is already provided in the folder. So if you go into the folder and you double click the Twitter crawler, this notebook, so this is what it looks like. So basically, Carla has already demonstrated you how to crawl data from Twitter. And then basically what I am having here is a kind of extension of what she already showed you. And also I will quickly explain the, let's say, how it works exactly. I mean, how the data are collected from the web page, and then why we need to open an web page and kind of do a, let's say, robot to scroll it down automatically. So yeah, let's start with this notebook first. So basically, I have 4, let's say, sections or chapters. The first will be a step-by-step guide. And then within each chapter, I have subsections, and then you can always open it and close it, and then to check the code and then run the code. I will do this later. And then for the second and third will be the 2, let's say, type of executing the crawling missions or tasks. One is focusing on, for example, different parameters that says I want to cure by key, I want to download by keywords, or a keyword plus locations, or simply locations, or geo coordinates. And then the third one is, for example, I want to do it on top of a geo grid, which means I have a list of geolocations and I want to collect data one location after the other. And then the last section is about managing the tweets, which means we can visualize the data we already downloaded. We can kind of make hyperlinks, and then we can do simple queries on top of them. So this is the structure of this notebook. And then before I go into the notebook, I will quickly explain how this notebook works by visiting this web page of Twitter. So if I say twitter.com, I will skip these parts. So if we say twitter.com, then sign up. Cancel. I don't want to sign up. Maybe I say /search. Okay, so basically this is what Twitter looks like. Everybody knows it. And then how we are working with it is simply, for example, you see that here's a box that says search Twitter. We can type anything here. For example, Carla just show you to search Tokyo, KYO. And then you get all the tweets regarding Tokyo. And then if you pay a little bit more attention, you see that actually the web address showing in our browser has changed because we did something in this interface. And of course, if we change to some other things, for example, ETH Zurich, then you see that this web page link changes as well. And then this is basically this is the key how we use Mathematica to connect to Twitter and to do crawling automatically. And more specifically, if we go to advanced search, we see that actually Twitter allows us to not just only search by keywords, but also have some additional information. For example, I only want the dates. I want the tweets from between certain periods, for example, or the tweets that are published by certain people. So basically, these are those kind of filters that we can apply to our query. And for example, if I say I want the tweets from February the 4th last year to, I don't know, I don't say to when, and then I say search. And then basically you see, okay, I need to specify the keyword as well. I say ETH Zurich, and then the dates will be from January the 3rd last year, and I do the search. And then basically you see these are the results that are since last year, and then correspondingly you see that in the web address there are also information specifying that here I'm asking for ETH Zurich, and here it says since, and then there's a date. And then basically this is how how we can, let's say, access different type of content from Mathematica. And how we download the images and text here is by analyzing the source code of the web page, because we all know that what we see here is the rendering of something that is hidden behind. So for example, if we say inspect, then we actually on the right we see the source code of this web page, and then for each element we see on the left there's always a certain, let's say, code corresponding to it, and this is what our crawler do. The crawler simply let's say goes through the source code of the whole web page and then look for certain interesting part. For example, where are the images and where are the text, and then get this information out and then save them in some other kind of format. For example, images as JPEG files, and then the text as I don't know, JSON text packed into one file, for example. And then basically this is the principle how it works. And then, for example, you see that for different images, they correspond to different parts of the source code of the web page. And then here you see it's actually a very complicated source code. So basically, for us, we are not interested in analyzing this source code because this should be done by the machines. And for us, we are more kind of interested in what kind of information we should collect from in this way, using these tools, for example. And then, so here I've done a little a very quick introduction on this, and then now I will show you how this crawler works. So, and also here there's a text specifying the version of this file. So probably if we made anything, if we made any updates, then we will change the dates here, and then of course we will distribute it to you, and then just please make sure that you are using the latest version. So we simply use the dates as our version number, so that it's easy to get. So first, a step-by-step guide. So basically, I've already shown you how to build a query. How to search, how to search tweets from their web interface, and then basically here we can do the similar things without manually typing on the web browser. For example, by manipulating the web addresses. So for example, here I can say I want the keyword of ETH Zurich. So I shift enter this cell. Yeah, I click yes. And then it says ETH Zurich. I say since, let's say, September 1st, 2018, and then until I say none, because I don't specify. And of course, you can specify it if you are interested, or if you want to narrow down your let's say scope of search. And then I run this, and then basically I get 2 dates, and then with these keywords and 2 dates I can build a query. And if you pay attention, that basically this is a part of the text that appeared in the web address we've seen a few minutes ago. This is one way of building the query. It's by search by keywords, or we can do it by location. And then, for example, but I have to just mention that with this tool you should only run one. If you run the other, then the result will override the previous one. So just make sure that you select the proper one, and then before starting the next session, which is the start crawling. So I will first demonstrate. No, I think I would only demonstrate search by keywords, and then you can try yourself with search by location, I think. And it's also simple. So here you specify the location and then the range, which means the radius that you want your tweets to be collected. And also the locations and the range are converted into coordinates, and then the range measured by miles, and then similarly you specify dates and then build a query string. I will skip this second approach and only focus on the first approach. And then so since we already have our query, we can now start a web session, which means we open a web browser that is controlled by Mathematica. I will split the screen into two so you can see it. And then the key idea is to use this web browser to manipulate or mimic how people, let's say, interact with this web page, because usually Twitter don't show you everything for, let's say, efficiency reasons and some other reasons. Because with one web page, if you try to load everything, then it will be super slow and very expensive. And then therefore, the trick is that every time you scroll down, you see that the length of this web page changes. And then this is how you can get more data from this web page. And this is exactly what we are going to do with this browser, with this crawler. So basically, I can specify, for example, how many iterations of scrolling down I want to make. For example, here I say I want 5 iterations as a demonstration, and then basically you can have more. And then I repeat this scrolling down automatically with this code, and then you see it's kind of repeating the scrolling down process. We just wait a little bit until it finishes. Yeah, 5 times. And then you see after that we can run the following code to obtain all the tweets we have. For example, if we run this, it says we get 12 tweets, not a lot. And then we can, for example, show the first one. This is the first one. We can also show all of them. And then for each one, there's a link. You can click it, and it will bring you to the original source of this tweet. Yeah. And also, the similar rules applies for everyone shown in this column. Yeah. So this is a very simple. This is a very basic example, and then of course, in the end, we can download all the tweets and then the text. For example, here I say I run this cell, and then I need to specify at which location I would like the files to be saved. I would say, for example, desktop code. I will use a new folder called tweets, for example. Yeah. I choose it, and then it says running. So I wait a little bit. Yeah, it's finished. So, and if we go into this folder, we see that it creates one JSON file and one folder. And they have the same name, and if we enter this folder, actually they are the pictures we see from the tweets. Right. And this JSON file contains the metadata and also the text of each tweet. So please make sure that you don't delete them, and then please make sure that these two guys always stays at the same location. So this is kind of important. And also, when everything's done, we can say delete object. We can close this web session so that the web browser is closed. And then so that's it. That's the very short introduction of how this crawler works. And then now I'm going to show an automated version, which means so basically the first one is a kind of explanation, and then in practice we don't use the first one because we simply don't want to run this one line after the other, let's say manually. And then actually we can do it in a more efficient way, and this is why in this notebook we have the second and the third chapter or section. So the same. So it's similar story that we have two steps. The first step that we need to specify the parameters. So, for example, how I want to crawl the data, or either by keywords, yeah, or by keyword plus location, or by location, or by geo coordinates. And then here, I think I will do it by location name maybe, because we see how keyword works, right? So I will do by location. And then here I say location is ETH Zurich. So this is the same box that you've seen before when Carla explaining her parts. So this box you can use control equal to make it show out, and then you type ETH Zurich, and then you press enter. And then Mathematica will interpret it as, you see here, the university, and then the full name of this university. So this will be our location. And then, of course, the range is like, because every tweet has its own geolocation, and then basically we filter those tweets out. We filter those that are too far away from our location out, so that we focus on those that are kind of posted near ETH Zurich. So we specify these two, and then we say since September the 1st, 2018, and until, let's say, none, and then we do 5 iterations, right? And then we run this, and then again, we need to specify at which folder we would like to save our data. So I will simply choose the same location I've used, which means this folder tweets, choose. Yeah, and then that's it. That's all the parameters this crawler needs. And then the second part will be start crawling. So basically, here you don't need to touch anything. You simply need to run it. Yeah, it will again pops up web browser, and then you see that the zooming level has been adjusted so that by each iteration you can actually access more data than the normal, let's say, zooming level. Yeah, and then we can wait for 5 iterations. Yeah, it's done. And that's it. You see, that's actually very fast and simple. And if you go to our folder, you see that there's a new folder and new file created, let's say, later, which means this is the recent result we have. And if we enter it, you see that actually we have many pictures in it. Yeah. How do I do it? Left and right. Yeah. Yeah. These are the images coming from the tweets. And if we can open this file with, for example, text edit, then these are the metadata for each tweet we have. So basically, don't touch these two files. Just make sure that they are kind of staying together at the same location. And then, yeah, that's an example how this works. And for example, you can try different way of building the query. For example, by a geo coordinates. For example, here I specify 1 geo coordinate. We can check it in Google where it is. Yeah. Oh, actually it's ETH Zurich. So maybe I go to somewhere else. Maybe I say, yeah, let's do Hauptbahnhof. Yeah. So if you click on the Google map, you see that actually it brings you to, come on. It will show the geolocation at the bottom of the web page, and then you can copy this. Hopefully I copied it correctly. You can copy this geolocation back into Mathematica. Yeah. No, it's not correct. Well, sometimes a little bit tricky to. Yeah, I think here. it's also in the web browser, right? Yeah. So I copy it from the web browser, and I paste it into Mathematica. Yeah. So I can do the same similar thing. I can do it by geolocation. Also, I say I want 2,000 meters, and then let's don't specify anything about the date, and still we do 5 iterations, right? And also I need to specify the location again, and it should be desktop code tweets. Choose. Yeah. So these are all the parameters we need before running the crawler. And then again, we run the second cell without touching anything, simply shift and enter. And then we see that the data is crawling for our new settings, new parameters. 2 iterations, 3. Yeah. And then if we go back to the folder again, there's another folder created, and here are the images. Yeah. Yeah. Okay, so, and for the second chapter, I think that's it, because basically what you need to play with is the first part, how to use different ways of building the query, and then for the second part, it will be always the same to run this crawling machine automatically. And then for the third chapter, I think I will skip, because it's the same story that you, for example, you specify a location and also a radius, a range, and then Mathematica will generate an orthogonal grid on top of the location and the range you selected. For example, here, if I run this guy, you see that in this graphics there are actually 5 by 5 black dots on top, and then basically these are the locations where the tweets will be crowded. And then also again specifying the time if you want to narrow it down a little bit. And then for the rest is the same. Then you run the second session, this automatic machine, and then it will brings you all the data. The only thing that you need to do is to wait a little bit until it finishes. And also, yeah, if you want more data, so in principle you can add these iterations to, let's say, 10, 50 or more, so that it goes through the web page, it stays on the web page longer, and then it gets more data. So I will not run the third part, and I will go to the fourth part. So the fourth part basically it's a kind of way that we can check if our work has been done correctly. So for example, at the very first beginning, we need to specify where our tweets have been saved. So because this working folder is already had something, so you see this path, users, color, desktop, code, tweets. So basically I will skip this cell, and also unless you, for example, you close this notebook and reopen it, or you have moved your tweets to somewhere else, in principle, after you crawling the data, you don't have to run this cell again. Yeah. And then in the second part, I will import all the data from this working folder. Yeah. So it says I have 92 tweets in total, and I have some images as well. So then, since I have 92, I can, for example, I can show the 20th tweet, yeah, 20th element. So this guy, and also I can go back to its original location. Yeah, this is the tweet. Also, I can change it to, for example, 80. then this is something else, right? And of course, we can make a column and then to see what's going on. And because these tweets are random selected to make the column, so every time you run it, there's something different. And the last example I would like to show is that with the data we have, we can already start to make some basic search, for example. Because since we collect some tweets from near ETH, so maybe we can search for lecture, keyword lecture, to see if there are any tweets contains the keywords lecture. Yeah, actually there are a lot. So if you go to this first one, yeah, it tells you the full set of my spring in 2019, undergraduate digital design, blah, 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 lectures at ETH Zurich. Also, if we go to let's say this guy, yeah, his farewell lecture in the main building of ETH. So, and of course we can change something else. If I'm not sure if I use the correct date. Let's say virus. Do we have anything? Yes. Yeah. You don't need to wear any facial masks against the coronavirus. Yeah. So I think basically that's it for this Twitter crawler, and just to emphasize what needs to be done is that please go through, for example, these step-by-step guides to get a kind of idea what it is about, and before start your crawling task, ask you and your partner, let's say, what kind of question you are interested, and what kind of data may suit, let's say, your question. For example, you are interested in, let's say, building facades in 3 cities, then probably you can collect the tweets by keywords or by locations of these 3 cities. Yeah, for example.
Last lecture we already asked you to start thinking of the project you want to work with. So this short paragraph that you have to deliver today should be more precise than the one you sent us before. And this third paragraph, what is helpful is because it should include already the data you want to crawl. So this is how we know that you're following the course, and we will also ask you to send us a screenshot of the folder where you have been downloading the data, so we can keep track on how you're doing that. So together with the short paragraph we asked at the beginning that is more specific from the one that you've been asked the last lecture after Diana's presentation. Now you have to send as well a screenshot of the folder where all of the data is being crawled. So then we can check that that it's consistent to the paragraph that you wrote about the project you want to work with. And so to clarify, you've been working in groups of 2 or 3. So also in the mail I sent you a link where you can add your names and the title of the project, so we keep track on that as well. So then that will be
it off. Yeah.
Thank you, and then see you next week.
See you.